Hi, folks. I'm out of practice, so hopefully it'll go well. We're going to be doing Algebra 1 IXL V.8, which is evaluate expressions using properties of exponents. So we're going to probably do more than one type and simplify some expressions. So let's take a look and see what we get. Okay, so in this particular case, I wonder if we're supposed to find the value without the exponents, probably. So what I'm suspecting we're supposed to do is take 5 to the 5th over 5 squared, which of course is 5 cubed, but that happens to be equal to 5 times 5 times 5, or 125. One thing you want to do is memorize some of your smaller exponentials. So there it is. Let's try 125 and see if it likes that. Of course, what you don't want to do is just push buttons on your calculator. You want to do these. 4 times 4 is 16, or 2 to the 4th, however you want to think of it. And 4 squared is 16 times 16 is 256. And 3 to the 8th over 3 to the 4th, I'm subtracting the exponents. 3 to the 8th, I'm going to write it because you might not be able to see it well, is 3 to the 4th. And of course, that's 3 times 3 times 3 times 3. And 9 times 9 is 81, isn't it? Let's see what we got here. Okay, so now we're looking at 2 squared is 4. That's 2 squared in the numerator. And 4 squared is 16, but then we reduced that to 1/4. I think they put the division line in case we want to put in some expressions later. 16 times 16 is 256. 6 to the 6th, which is a nice big number, divided by 6 to the 4th gives us 6 squared, which is 36. Oh, so 36, there we go. Going pretty quick, not too bad. Oh, so this one's a little different. 81 times 27. Not sure how to make this any faster. Okay, I'll multiply it. I'm going to multiply it in my head. And the way I'm going to do this, I'm going to multiply using the FOIL method. So I'm going to multiply 1 times 7, get the 7. Then I'm going to multiply the inner and outer terms, and that's going to give me my tens and my carry. So I've got 8 times 7, 56, and 58 gives you 8, carry the 5. And the 16 with 5 more is 21. So what I did was I'm using the idea of place value and 80 plus 1 times 20 plus 7. And so I'm multiplying it out using FOIL. So I multiplied the 1 times 7, and the 20 with the 560 gives me 580. And then I added the 500 along with the 1600, which gave me 2100. So anyway, there it is. 187. I assume it's right. I did it twice. Probably good enough. All right, so we're looking at 5 to the 9th over 5 to the 7th. I'm rewriting it because it's a little hard to read. 5 squared is 25. Oh, now this one's a little more interesting. This is 2 to the negative 2 over 2 to the negative 1. And what you do, of course, is move across the division line, the 2 and the 2 squared, which is 4, which of course is a half. Make sure you reduce these guys. This is going to be 27. That's 3 times 9, which is 27. But of course, I'm thinking of it as 3 to the 3rd. That's still 27. Always good to know. Okay, now this is a little more interesting. So this is 5 over 10 to the negative 3. A lot of people are going to mess this up because the negative is in the denominator. It needs to get moved up. So this is really 5 times 10 to the third power. Move it across the division line, change the sign. Well, some people are going to multiply the 5 times the 10 and get 50 cubed, which this is not. This is 10 cubed, which is 1,000. So this is 5,000. Let's see, what do we get here? Now this time we have 8 over 49 because the 7 to the negative 2 gets moved to the denominator. So I'm looking at 8 over 7 squared, or 8 over 49. And of course, there's no common factors. This is going to be 4 cubed is 64. So it's 4 times 4 times 4 is 64. And then that 9 to the negative 1 gets moved to the denominator. So we're looking at 64 over 9. I don't think there's any reducing or anything you have to do with that. Of course, there's no common factors because these all have factors of 2, and this one has factors of 3. So anyway, something to think about. All right, what do we got here? Okay, so my 3 to the 7th goes in the denominator, and I've got 3 to the 1st times 3 to the 5th, which is 3 to the 6th. That's 1/3, isn't it? Because these 6 simplify out with 6 of these. Okay, 6 to the 0 power is 1. It's just getting multiplied, nothing happening there. The 9 is in the numerator, and the 4 is in the denominator. That's it. 9 quarters is 225, isn't it? All right, so we've got 4. 2 squared is 4. And in the denominator, we have 3 to the 4th power, which is 81. I want to memorize some of these. Let me put my eraser so I'm not writing these. Okay, now this one's a little different. This is 11. Oops, I need to write it. 11. And then we're moving that 5 to the negative 3 to the numerator, which gives us 5 to the 3rd. Now this happens to be 125. And 125 times 11, a lot of people are going to just grab that handy dandy calculator. But I'm going to show you a nice trick for 11s. All I'm going to do is I'm going to write this last digit, 5. Then I'm going to add these and get 7. Then I'm going to add these and get 3. And then I'm going to write that first digit, which is 1. 1375. Now, one more time. Times 11. Doesn't matter how ugly, by the way, that's 1375. It doesn't matter how ugly or big your number is. In fact, I used to race people with a calculator if you make a nice long one. The problem being that it's hard to do the carries in your head. But as long as all of your numbers add up to something less than 10, it's real easy to multiply by 11. For example, 1, 2, 3, 4, 5 times 11 looks hard, but it's just 5, 9, 7, 5, 3, and the 1. And there you go, 135,795. Anyway, there it is. Let's do another one. Okay, we've got 10 to the 5th in the numerator, and then we've got a 10 to the 5th times 10 squared in the denominator. So these guys cancel out, and I just get 1 over 100, don't I? And you can do it other ways, but it seems the easiest to me. Now let's see what we got here. Okay, we've got 2 to the 0 in the denominator, because that's a 3 and a negative 3 in my exponents, which is 1. And I have a 2 to the 4th in the numerator. So this is what I'm looking at. This, of course, is just 1. And 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. I recommend memorizing those powers of 2. They're really powerful. For example, 2 to the 10th is 1,024. It's just one of those things that, and then 2 to the 9th is going to be 512, and 256 is before that. Anyway, let's see. We've got a whole bunch of 11s. This looks cool. Well, notice that I have an 11 to the -5 and an 11 to the -5. I could switch their positions and then cancel them, but it's the same value. And then I have 11 to the 4th, and I have 2 left in the numerator, which is 121. And we've got to do quite a few here. All right, I'm going to go a little faster. That's 10 to the 5th and 10 to the 6th. So I have 1/10. And all right, now we've got a little more interesting problem here. I've got 11 cubed over 5 times 11 to the 5th. I move the 11 to the -3 up, and I move the 5 down. Well, this is going to be 1, and that's going to be 121 times 5. So I have a 1 in the numerator, and then I have 605 in the denominator. I use the double and half method sort of in this with a carry. But anyway, there it is, or a carry over 1. 605, I should have said remainder, but there it is. It's good. All right, what's this next one? All right, we've got a 3 to the 6th and a 3 to the 9th. I went ahead and moved my negative exponents. And I also have an 8 squared, and I have a 7. So we've got a lot of stuff going on here. First of all, let's simplify these guys. That's 3 to the 3rd power. And then my 8 squared is 64. So I'm looking at 27 times 64 in the denominator. Now, a lot of people are going to go, well, wait a minute. How do I know I can't reduce? Well, this is all 3s. This is all 2s, or 8s if you like. And 7 is a prime number, so there is no reducing it. So I have a 7 in the numerator. And then I have 27 times 64. Shall I do the FOIL method again for you? That's 28. So I have 8. I'm carrying the 2. So I just remember to bring it. Now comes the hard part. 42 and 8 makes 50. So I carry the 5. And 2 times 6 is 12. So it's 1728. Probably should check it, but I'm pretty sure it's right. It's a little faster maybe than doing it, the old-fashioned way where you're doing your step-by-step method, 27 times 64. We're doing the same thing, using this algorithm. 4 times 7 is 8. We carry the 2, and we get the 108. Notice that I carried the 1 myself. Then the 6 times 7 is the 2, and the 4, and I've got 6 times 2 is 12, 16, and that is 1728, isn't it? All right, got a whole bunch of 12s. Let's see what we got. We got 6 in the denominator, and we have 8 in the numerator. That's 12 times 12 to the 7th, which gives me 12 to the 8th. These 5 12s get moved to the denominator and give me 12 to the 6th, which is 12 squared, 44. Lots of things you could do with that. A lot of people are going to want to grab their calculator and do the exponents without reducing them. Probably not a good plan. That is 11 to the 0 power there, which is 1. And I do have an 8 squared. I'll just write it like this. 8 squared over 2 to the 4th. Now, it just so happens that 2 to the 3rd is 8. And I could simplify it that way, but I think it's easier to just do the 64 over 16. And a lot of people have trouble with that. It just happens to be 4. Another way to look at it is that you could think of this as 2 to the 3rd times 2. And this 8 cancels with one of those. And 8 over 2 is 4. So whatever. It all works. And it looks like we got 2 more to go. All right. I've got 3 cubed, and I'm going to leave them like that, times 6, and then I've got a 9 squared. But that's really 3 to the 4th, isn't it? 9 squared is 3 to the 4th. Now, a lot of people are going to insist on saying, oh, there's a million things you could do here, but watch this. 3 times 2, isn't that 3 to the 4th? So anyway, there it is too. That's the way I kind of did it in my head, just so you can see what I was up to. And the last one. Okay. There's 12 squared in the bottom. You know what? I'll do the last one. I'll write it out just to be careful. Okay. 12 squared cancels 12 over 10. We do have to reduce to 6 over 5. That is 1.2, by the way. And we're done. And I hope you guys will go to Mastery and practice a little bit. You'll notice I didn't grab my calculator. It's a good practice to play with your numbers, okay? I'll see you back again. Bye, everybody.